What's up, Xavier Roboticists? Okay, we're jumping right in here. All right, so first of all, we need to figure out what our two sensors are, right? Our front sensor and our side sensor. We want to know what those ports are. So I'm going to jump into the simulator, and I'm going to go to port configuration. And my middle range sensor, which would be my front sensor, is in analog 1. And my right range sensor, which would be the one sensing the wall to my right as I follow it, is going to be analog 2. So I also want to make sure that I set my default board to the 2013 board, because this has a wall going all the way around the outside, and my goal is to go from this starting position and stop here before I touch this wall. So I know that my front sensor is 1 and my right sensor is 2. So front sensor 1, right sensor or side sensor 2. Alright, so my basic algorithm, which we've talked about already, is while my front sensor is not seeing the wall up ahead, right? While that's true, while I do not see the wall up ahead, well, if we look at this simulator and the way it works, if the sensor is not detecting anything, it reads, I think, a 1023 or something like that. The minute it gets into range, it gets a smaller number. That's actually the opposite of what happens to the robots on the table. Most of your robots, their sensors in the game on the table, the physical robots, the sensors will actually go up as you approach the wall. So you'll get like a 2900 reading if you're close to the wall, and then it'll go down from there as you move further away from the wall. So thinking about just running this for the simulator, I need to write a logical test here for my loop that's going to keep me in the loop. See, this has to be true. Whatever this is has to be read as true in order for me to stay in here and do this stuff, which is the stuff that's going to actually get me to follow the wall, right? Veering away from the wall and veering toward the wall. So I'm never really going forward. I'm just sort of, serpentining back and forth, veering away, veering toward, veering away, veering toward, hopping back and forth between these two conditionals the whole time while my front sensor is not seeing the wall up ahead. So you might want to write something like this for your main logical test, right? While analog front sense, that would be analog port 1, is less than or equal to target. Now we would have to come up with int target equals and then come up with a number here. You guys fill in the blank, whatever your target is. And that's a number that's going to be like sort of your sweet spot, right? If I get any closer than this, I'm too close. And I don't want to get much further than that either. So it's just one number. And for my side sensor, this is what I'm using to sort of follow the wall, right? So my front sensor is going to be detecting for this wall here, up ahead. But my side sensor is going to be detecting this side wall the whole time. I'm just going to be kind of moving along that side wall. So that side sensor is either going to be moving toward the wall or away from the wall based on what we write as our logical tests in here. It's going to be similar, right? But it's going to be analog side sensor, right? And then you can use a different target if you want for that. I don't know if it's a different target, or you decide. You figure it out. But then you'll have functions that will veer you away from the wall and functions that will veer you toward the wall, and you'll have to define those functions. And I'd also like for you to have printfs within these functions, right? So that I know what the robot's doing at all times. So that's very simple, but comment your code, right? Heavily comment and have, printfs throughout, and see if you can get this thing following the wall. For those of you who are in the classroom, you're going to write this for the robot that you have physically and that you've been working on. And hopefully the next time we come in, that would be Friday, we can actually see some of these robots successfully following the wall and getting to that first corner, if not completely solving the course. I have confidence in your ability to get that done. For those of you who are remote or both partners are not in, and so you're all remote, you guys are going to be working in the simulator, okay? Because you can't work on your physical robot if you're at home together. So you're going to be using the simulator to try to solve this. And each person is responsible for turning in their own version of this on Classroom, right? And there's a topic on Classroom. If you go to Classroom, you'll see you guys are section 1, I believe. So we go to Classwork and Wall Follow Challenge Sim. Okay, for those of you guys who are all remote, you're going to submit your code document and take a video of the SimBot actually executing your code, and that is due November 19th. What is that, Thursday? Thursday at 8:30 a.m. So I will not actually see you again until Friday, so I'm going to change this due date for you guys so that it's Friday morning. Okay? So get that done, and best of luck. And if you have questions, ask each other, rely on each other as resources, but also feel free to reach out to me. All right, good luck.